Hello children. Today we are going to learn Unit 16 Applied Chemistry from your ninth standard science book. Come, let's enter into this video session.
Hello, children. Today we are going to learn Unit 16 Applied Chemistry. Introduction. Food, medicines, cosmetics, dress materials, and gold covering ornaments are some of the items used in our day to day life. They may differ in nature and applications, but all these are associated with chemistry. They are made up of synthetic and natural chemicals. We face lot of difficulties in different means to lead our day-to-day life. Such difficulties make chemists to come out of new ideas and theories. For example, when people suffered from disease, new chemical compounds were synthesized and used as drugs. New techniques were also developed to diagnose disease. When farmers suffer due to low crop yield and pest related problems in crop field, chemists developed new chemical fertilizers and pesticides to combat these issues. Thus, chemical principles and theories are applied to various fields in order to achieve specific results or to solve real world problems. This is called applied chemistry. Come, let us discuss various branches of applied chemistry and their significance. Size of nanoparticles. The word nano has been derived from the Greek word nanos, which is designated to represent billionth fraction of a unit. The following examples may help to illustrate how small the nanoscale is. 1 nanometer is 10 to the power minus 9 or 0.000000001 meter. A nanometer and a meter can be understood as the same size difference as between golf ball and the earth. Our nails grow 1 nanometer each second. The virus most usually responsible for the common cold has a diameter of 30 nanometer. A cell membrane is around 9 nanometer across. Applications of nanochemistry. The range of commercial products available today is very broad, including stain resistance and wrinkle free textiles, cosmetics, sunscreens, electronics, paints, and varnishes. Nanochemistry is applied in all these substances. Some of them are given below. The metallic nanoparticles can be used as very active catalysts. Nano coating and nanocomposites are found useful in making variety of products such as sports equipment, bicycles and automobile etc. Nanotechnology is applied in the production of synthetic skin and implant surgery. Nanomaterials that conduct electricity are being used in electronics as minute conductors to produce circuits for microchips. Nanomaterials have extensive applications in the preparation of cosmetics, deodorants, and sunscreen lotion. Nanoparticle substances are incorporated in fabrics to prevent the growth of bacteria. Nanochemistry is used in making space defense and aeronautical devices. Drawbacks of nanomaterials in chemistry. Nanoparticles are unstable when they react with oxygen. Their exothermic combustion with oxygen can easily cause explosion. Because nanoparticles are highly reactive, they inherently interact with impurities as well. Nanomaterials are biologically harmful and toxic. It is difficult to synthesize, isolate, and apply them. There are no odd and fast, safe disposal policies for nanomaterials. Pharmaceutical chemistry. Pharmaceutical chemistry is the chemistry of drugs which utilizes the general laws of chemistry to study drugs. Pharmaceutical chemistry deals with preparation of drugs and the study of chemical composition, nature, behavior, structure and influence of the drug in an organism, condition of their storage and the theoretical uses of the drugs. Drugs discovery is the core of pharmaceutical chemistry. Drugs. Even though we use so many chemicals in our daily life, the chemicals used for treating disease are termed as drug. The word drug is derived from the French word drogue, which means a dry herb. According to World Health Organization, a drug is defined as follows. It is a substance or product that is used or intended to be used to modify or explore physiological system or pathological states for the benefits of the recipient. Characteristics of drugs. A drug must possess the following characteristics. It should not be toxic. It should not cause any side effects. It should not affect the receptor tissues. It should not affect the normal physiological activities. It should not be effective in its action. Source of drugs. The main sources of drugs are animals and plants. The modern manufacturer adopt many chemical strategies to synthesize drugs for specialized treatments, which are more uniform than natural materials. The following table shows various sources of drugs. Source of process drug. Plants, morphine, quinine. Chemical synthesis, aspirin, paracetamol. Animal, insulin, heparin. Minerals, liquid paraffin. Microorganism, penicillin. Genetic engineering, human growth hormone. Let's see the types of drugs. Drugs fall into two general categories. The drugs that are used in the treatment and cure of any specific disease. The drugs that have some characteristic effect on the animal organism but do not have any remedial effect for a particular disease. This class include morphine, cocaine, etc. Anesthetics. The drugs which cause loss of sensation are called anesthetics. They are given to patients when they undergo surgery. When patients undergo a major surgery in internal organs, some anesthetics are given so that they lose sensation completely. But when they undergo a major surgery in a specific part of the body, anesthetic is given to lose sensation around the particular part. Based on this, there are two classes of anesthetics as given below. One is general anesthetics, another one is local anesthetics. The general anesthetic, they are the agents which bring about loss of all modalities of sensation, particularly pain along with reversible loss of consciousness. For example, when a surgery is carried out on internal organs, these anesthetics are given. The patient loses consciousness for a specific period of time depending on the duration of surgery and get it back later. Local anesthetics. They prevent the pain sensation in localized areas without affecting the degree of consciousness. For example, dentists give patients this kind of anesthetics when carry out a minor surgery in teeth. Chemicals as anesthetics. There are three major chemicals which are used as anesthetics. They are nitrous oxide N2O. It is a colorless, non-irritating inorganic gas. It is the safest of the anesthetic agents. This is used after mixing general anesthetics like ether. Chloroform CHCl3. It is a volatile liquid. It has pleasant smell and sweet taste. With oxygen, it forms a toxic carbonyl chloride, hence it is not used now. Ether. Diethyl ether or simple ether is a volatile liquid. This is a mixed with a stabilizer 0.002% propyl halide. After absorption by tissues, it attacks the central nervous system and makes the patient unconscious. Analgesic. Analgesics are the compounds which relieve all sorts of pains without the loss of consciousness. These are also called as painkiller or pain relievers. These are effective in healing headaches, myalgia, and arthralgia. The analgesics are given either orally or applied externally. In general, externally applicable painkillers come as gels. Antipyretics. Antipyretics are the compounds which are used for the purpose of reducing fever. They are taken orally as tablets or capsules. The most common antipyretics are aspirin, antipyrin, phenacetin, and paracetamol. Antiseptics. Antiseptic is a substance that prevents infection caused by disease causing microorganism or pathogens. Antiseptics either kill the microorganism or prevent their growth. Antiseptics are used externally to cleanse wounds and internally to treat infection of the intestine and blood. Antimalarial. Malaria is a vector borne disease which causes shivering and fever. It rises the body temperature to 103 to 106 degree Fahrenheit. It causes physical weakness with the side effects in liver, also causes anemia. Extracts of roots and stems of certain plants are extensively used as antimalarial. Quinine is a natural antimalarial obtained from chinchana bark, the last antimalarial discovered in 1961 is pyrimethamine. However, quinine, pyrimethamine, or chloroquine are some of the best antimalarials. Chloroquine is used specially to control malarial parasites such as Plasmodium ovale, Plasmodium vivax, etc. It is not used in curing the disease, it is used as an additive with other anti-malarial drugs. Antibiotics. Many microorganisms, bacteria, fungi, and molds produce certain chemicals which inhibit the growth or metabolism of some other disease causing microorganism. Such chemical compounds are known as antibiotics. There are three main sources of antibiotics: bacteria, fungi, and acetinomycetes. The original antibiotics, like a lot of today's antibiotics, are derived from natural sources. Certain plants, extracts, essential oils, and even foods have antibiotic properties. Example: honey, garlic, ginger, clove, neem, and turmeric. Antacids. Quite often, after eating oily and spicy food, one may feel uncomfortable due to some burning sensation in stomach, food pipe. This is due to imbalance in the acidity in the stomach. Certain drug formulations provide relief from such burning sensation. They are known as antacids. Antacids are available in tablet as well as gel syrup forms. These antacids contain magnesium and aluminum hydroxides in addition to flavoring agents and color. Electrochemistry. We use so many electronic devices like mobile phone and electrical devices like torch light in our daily life. Electricity produced by the battery is a key factor which makes these devices to function. But how does battery produce electricity? Because it contains some chemicals in it. The chemical reactions that take place in the battery produce electricity. So, when scientists realize that chemical energy can be converted into electrical energy and vice versa, another branch of applied chemistry was developed. It is electrochemistry. So, what is electrochemistry? Is a branch of chemistry which deals with the relation between electrical energy and chemical change. It is mainly concerned with the process taking place between the electrode and solution having ions called electrolyte. Electrochemical cell. So many chemical reactions take place around us. Do all they produce electricity? No. Only redox reactions that take place in a specific device can produce electricity. The device that make use of a chemical change to produce electricity or electricity to produce chemical change is called electrochemical cell. Let's see the components of electrochemical cell. Electrode. It is a solid electrical conductor made of metal, sometimes non-metal like graphite. A cell consists of two electrodes, one is called anode and the other is called cathode. Electrolyte. It is made up of solutions of ions or molten salts which can conduct electricity. Cell reaction, oxidation reaction and reduction. As we know already, an oxidation is loss of electron. In electrochemical cells, oxidation takes place at anode. Metal gives metal ion plus electron. Reduction. It involves gain of electrons. Reduction takes place at cathode. Metal ion plus electron gives metal. Types of electrochemical cell. Based on the nature of energy conservation, electrochemical cells are broadly classified as below. Galvanic cell. Galvanic. It is an electrochemical cell which converts chemical energy into electrical energy. It produces electricity from chemical reaction. It consists of two off cells, namely an anodic L off cell and cathodic off cell. In anodic off cells, the anode is in contact with its electrolyte, whereas in cathodic off cell, the cathode is in contact with its electrolyte. The anode and the cathode are connected by a conductor wire. The electrolytes of off cells are connected through a tube containing a saturated salt solution. It is called salt bridge. Thus, in galvanic cell, both the off cells are kept separately but stay connected electrically. Let's see how does a galvanic cell produce electricity. At anode, oxidation takes place which releases electrons. These electrons are attracted by cathode and hence the electrons flowing from anode to cathode are gained in reduction reaction. As long as redox reaction proceeds, there is a flow of electrons and hence electricity. Electrolytic cell. It is an electrochemical cell which converts electrical energy into chemical energy. In electrolytic cells, electricity is used to bring about chemical reactions. Here both anode and cathode are in contact with same electrolyte and thus the off cells are not separated. As seen in galvanic cells, electrolytic cell also involves redox reaction. We get electricity from galvanic cells, but electrolytic cells use electricity. Then how are they useful? In electrolytic cells, when electricity is passed to electrolyte, it dissociates into its constituent ions. These ions undergo redox reaction, forming the respective elements. This phenomena is called electrolysis. So, electrolysis is a process by which an electrolyte is decomposed into its constituent elements by passing electricity through its aqueous solution or fused molten state. Significance of electrochemistry. The subject of electrochemistry is of great significance. Some of its applications are given below. It has been used to discover important technical processes for the production and purification of non ferrous metals and for the electrosynthesis of organic compounds. Electrochemistry is used to predict whether a particular reaction will occur or not. The detection of alcohol in drunken drivers is possible through the electrochemical redox reaction of ethanol. Production of metals like aluminum and titanium from their ores involve electrochemical reactions. Lead acid batteries, lithium ion batteries, and fuel cells are based on electrochemical cells. Fuel cell is used to bring about direct conversion of chemical energy into electrical energy. Radiochemistry. Radiochemistry is the study of chemistry of radioactive and non radioactive isotopes. It includes both natural and artificial isotopes. Radiochemistry mainly deals with applications of radioisotopes to study the nature of chemical reactions of non radioactive isotopes of elements and applications of radioisotopes to various fields. Let's see the applications of radioisotopes. Radioisotopes can easily be detected and estimated quantitatively, so they are used in radiochemistry for various applications. Radiochemistry mainly deals with study of chemical reactions of non-radioactive isotopes using radioisotopes. In addition to that, it could find applications in medical field and environmental management also. Let us list important applications of radioisotopes. Radiocarbon dating. It is a method by which the age of fossil wood or animal is determined using C14 isotope. Diagnosis. Radioisotopes are found very useful to diagnose and understand many diseases. Radioisotope in diagnosis. Radioisotope diagnosis used for iodine 131 is location and detection of brain tumor, thyroid gland disorder. Sodium 24 location of blood clot and circulation disorders, pumping action of heart. Ion 59 diagnosis of anemia, pregnancy disorder. Cobalt 60 diagnosis of cancer. Hydrogen 3 water content of the human body. Radiotherapy. Radioactive isotopes are used in the treatment for many diseases. This kind of treatment is called radiotherapy. Let's see the radioisotopes and treatment used for. Gold 198 is used for cancer. Iodine 131 is used to treat the hyperthyroidism and cancer. Phosphorus 32 for blood disorder and skin disease. Cobalt 60 is cancer. Dye chemistry. Human is always fascinated by color because we are living in a colorful world. We could see so many colors in plants and their flowers. We eat colored foodstuffs and use numerous colored materials in our daily life. Do you know how do they get colored? Because they contain some kind of chemicals in them which are called colorants. The uses of colorants by mankind for painting and dyeing dates back to the dawn of civilization. Until the middle of the 19th century, all colorants applied were from natural origin. For example, inorganic pigments such as soot, manganese oxide, hematite were used as colorants. Organic natural colorants have also a timeless history of application, especially for coloring textiles. The organic compounds that are used as colorants are called dyes. After the evolution of modern organic chemistry, many kind of synthetic dyes were prepared and used by mankind. Dye chemistry is the study of such kind of dyes. It provides us information on theory, structure, synthesis and applications of synthetic dyes. Characteristics of dyes. All colored components are not dyes. Dyes are those colored components which can be firmly fixed in fabrics by chemical or physical bonding. So, a dye should have the following characteristics: it should have a suitable color, it should be able to fix itself or be capable of being fixed to the fabric, it should be fast to light, it should be resistant to the action of water, dilute acids, and alkalins. Based on method of application, acid dyes. These are acidic in nature and used for dyeing animal fiber and synthetic fibers. These can be used for protein fibers such as wool and silk. Example: picric acid, naphthol, LOS. Basic dyes. These are basic dyes containing basic group NH2, NHR, NHR2. They are used for dyeing animal fibers and plant fibers. Modern dyes or indirect dyes. These dyes have a poor affinity for cotton fabrics and hence do not dye directly. They require pretreatment of the fiber with a more mordant. Mordant is a Latin word mortar is equal to bite, is a substance which can be fixed to the fiber and then can be combined with the dye to form an insoluble complex called lake. Aluminium, chromium, and iron salts are widely used as mordants. Example: alzarin. Direct dyes. They have high affinity for cotton, rayon, and other cellulose fiber. So they are applied directly as they fix firmly on the fabric. Example: Congo red. Vat dyes. It can be used only on cotton and not on silk and wool. This dyeing is a continuous process and is carried out in a large vessel called vat. So it is called as vat dye. Example: indigo. Agricultural and food chemistry. Agricultural chemistry involves the application of chemical and biochemical knowledge to agricultural production, processing of raw materials into foods and beverage, and environmental monitoring and remediation. It deals with scientific relation between plants, animals, bacteria, and environment. Goals of agricultural chemistry. Indian chemists and biochemists applied their knowledge and developed modernized agricultural practices which involve use of synthetic fertilizers, genetically modified crops and equipments. It aims at producing scientific nutritious food and feed the population in a sustainable way while being responsible stewards of our environment and ecosystem. Based on the issue and challenges in agricultural production, agricultural chemistry mainly focuses to achieve the following: increasing in crop yield and livestock, improvement of food quality, reducing cost of food production. Applications of agricultural chemistry. Soil testing. Crop plants may have different kinds of soil with varying pH. Soil pH is one of the main criteria to be considered for the selection of crop or remediation of soil. Soil testing involves determination of pH, porosity, and texture. Chemical fertilizers. Fertilizers are chemical compounds added to crop field for supplying essential micro and macronutrients required for crop growth. Ammonium nitrate, calcium phosphate, urea, NPK, nitrogen, phosphorus, and potassium, etc., as some of the fertilizers. Depending on the nature of soil, these fertilizers are used singly or as mixtures. Pesticides and insecticides. Crops are prone to disease caused by pests and insects. Chemically synthesized pesticides and insecticides are used to solve these issues. Chlorinate hydrocarbons, organophosphate, or carbamates are used as pesticides and insecticides. Food chemistry. Food is one of the basic needs of human and animal. The food we eat also are made of chemicals. Any human might require the following three kinds of food. Bodybuilding foods. These are required for physical growth of body, example proteins. Energy giving food. These are the foods that supply energy for the functioning of parts, human body, example carbohydrates. Protective foods. These protect us from defensive disease, example vitamins and minerals. Every human requires all these three kind of food in right proportion for the smooth functioning of the body. The diet that contain all these three foods in right proportion is called balanced diet. So food chemistry is the chemistry of foods which involves the analysis, processing, packaging and utilization of materials including bioenergy for food safety and quality. Goals of food chemistry. The main goal of food chemistry is to cater the needs of quality food to the population in a sustainable way. In basic research, food chemists study the properties of proteins, fats, starches, and carbohydrates, as well as microcomponents such as additives and flavorants to determine how each works in a food system. In application research, they often develop new ways to use ingredients or new ingredients altogether, such as fat or sugar replacement. Chemicals and food. Food we eat in our day to day life contains natural or synthetic chemicals. They serve different functions in human body. Nutrients. They are the most essential chemicals present in food. They are required for the growth, physiological, and metabolic activities of the body. They are natural or synthetic, example carbohydrates, proteins, vitamins, and minerals. Forensic chemistry. Forensic chemistry applies scientific principle, techniques, and methods to investigation of crime. Our daily newspaper is carrying a lot of news and incidents of chemical activities such as robbery, murder, sexual harassment, etc. How the crime department investigate and analyze it. In real life, the collection and analysis of evidence involve painstaking care and rigorous application of scientific principle. Let us see the forensic chemist in criminal investigation. Collection of evidence, analysis of evidence, collaboration, report of findings. In the collection of evidence, they collect physical evidence such as knife, instruments, materials, etc. in a systematic way and uncover their information using chemistry. In analysis of evidence, in criminal cases, chemists analyze substances such as blood and DNA to attempt to determine when and by whom the crime was committed. Collaborations. To solve the crime, they discuss with other fellow investigators like police officers, detectives, and other forensic scientists. Report of findings. Finally, they prepare a report of the conclusions of the analysis. Method of forensic chemistry. Fingerprint, biometrics, alcohol test. In fingerprint is one of the most important evidence in crime investigation. Fingerprints on smooth surface can often be made visible by the application of light or dark powder, but fingerprints on check or other documents are often occultments here hidden. Hidden fingerprints are sometimes made visible by the use of 9-hydrin. which turns purple due to reaction with amino acids present in the perspiration. Fingerprints or other marks are also sometimes made visible by exposure to the eye powered laser light. Cyanoacrylate ester fumes from glue are used with fluorescent dyes to make the fingerprint visible. Biometrics. The science that involves the study and analysis of human body prints is known as biometrics. The biometric system compares the body prints to the specimen data stored in the system to verify the identity of the person. Alcohol test. Drinkers can be easily identified by the use of applied chemistry. The person being tested blows through a tube which bubbles the breath through a solution of chemicals containing sulfuric acid, potassium dichromate, water, and silver nitrate. Oxidation of the alcohol results in the reduction of dichromate to chromium ion with a corresponding change in color from orange to green. An electrical device employing a photocell compares the color of the test solution with the standard solution. Giving a quantitative determination of the alcohol content, the test provides a quick and reproducible determination of the amount of alcohol in a person's breath and is a numerical measure of the amount of alcohol in the bloodstream. Applications of applied chemistry. Many of the advantages of applied chemistry are around us. It is inevitable. Applied chemistry has given us innumerable synthetic materials to lead our day to day life. The applied chemistry makes a most important contribution to our society. It makes a major contribution to the country's economic development and plays vital role worldwide. The products of applied chemistry are so widespread that they are used in our daily life.